Hamilton.
You're welcome to this video. This is Emmanuel Kadri of Hamilton Academy. In this video, we continue from where we stopped the other time. Remember that in the previous video, we say that when y depends on x, okay, it means y is a function of x. And then we did a couple of examples, and where we changed the where we changed the y to something looking like f of x. Now we just want to go a little bit further from where we stopped. This time around, we are talking about composite functions. Well, composite functions is what we could regard as function of a function. Composite function means the function of another function. Okay, so now let's have a couple of examples that can explain this further. Okay, understand first that a composite function is a function that bears another function. Okay, so let's quickly have some kind of example. If f of x is equal to 3x minus 1, and then we have another function, g of x, which means a particular function of x is 3x minus 1. Another function of x is, let's say, 3 minus 2x. Okay? A particular function of x is equal to 3x minus 1. Another function of x is equal to 3 minus 2x. All right? Now, the question now says, find f circle g of x, that's 1. Number 2, find g circle f of x. What they are just trying to say in this question is that f circle g, there is a small circle like a degree, okay? F circle g of x simply means, please take note, f circle g of x means f of g of x. So this is a function that swallows another function. It means that instead of us just have f of x is equal to something, right? Okay, and then something comes in and we replace that thing with all the x that we find. In this case, instead of replacing every x that we find in f of x, you know, f of x originally is, so f of x originally is what? 3x minus 1. You know, if I said f of 2 means that anywhere you have x, put 2. And then you keep putting the 2, and then you simplify until you get the last whatever, wherever you stop. Okay? Now, in this case, instead of us having a number, we are now having another function. So we are having a function instead of a number, replacing x. In the previous video, we had a number, okay, replacing all our x's. But in this video, we are having a function replacing all our x's instead of just a number. Something similar to the last example that we have in the previous video. All right, so that is what we are just trying to do here. So if you have f of x is equal to 3x minus 1, and then the question says find f of g of x. So f of g of x will now be 3, the 3 here, but instead of writing this x, we'll replace it with everything about g of x, excuse me. Instead of writing x here, we'll rather replace our x with 3 minus 2x, which is the value of g of x, because we are looking for f of g of x. Okay? So let me put it this way. F of g of x is f of whatever g of x is. In this case, g of x is 3 minus 2x. Just similar to the last example we treated before this video. Okay, that's just the same pattern. It means anywhere we now have x, because if f of x is this, then f of all this nonsense here will be 3 times the nonsense minus 1. You get what I'm trying to explain? So that's it. Then let's do it that way. So f of a particular nonsense is 3 nonsense minus 1. F of this new nonsense will be what? F of g of x, which is a new nonsense, okay, actually it makes sense, will now be equal to 3 multiplied by the old nonsense, that is 3 minus 2x, okay, then minus 1. So I just try that you won't be confused. X is what is being replaced by g of x. So g of x we know is 3 minus 2x. So instead of us writing f of x is equal to 3x minus 1, we say f of this thing that replaces x here will now be 3 multiplied by the thing that replaces x, then minus 1. Simple. Then you just, you break it down further. 3 times 3 will give you 9. 3 times minus 2x will give you minus 6x. Then the minus 1 that was outside before, you repeat it. So in that case, we have it that you just collect like terms. 9 and 1, they are like terms. Okay, so 9 minus 1 gives you 8. Then you leave this minus 6x, and then you got it. So which means f of g of x is equal to 8 minus 6x. Simple. Okay? Or you can say minus 6x plus 8 is also the same thing. Okay, if you are solving this question in an exam and we have a multi-choice question, if the option doesn't come this way, it should come this way. But either of the two is correct. All right? So what we just did here is that we put the negative 6 to the front and put the positive 8 to the back. But it's still the same thing. Okay? So whatever is the value of x is, we'll still get the same answer. If x happens to be 2, for instance, or to be 1, for instance, 6 times 1, minus 6 times 1 gives us minus 1. It's minus 6. So 8 minus 6, then that will be 2. If you put it this way too, okay, if you put 1 here, minus 6 times 1 is minus 6. Minus 6 plus 8 is still 2. So whatever is it, you will still get the same answer. So, all right, now let's quickly check the second one. The second one says g circle f of x. Okay, g circle f of x simply means g of f of x. That's what it means. You get it? So if you're looking for g of f of x, so it means we are going to have the g of x on its own. Actually, originally, g of x is 3 minus 2x. Originally, g of x is 3 minus 2x. So then g of f of x, and we know that f of x is 3x minus 1. So we say g of f of x will be equal to, anywhere we see x, we replace it with what? F of x. Knowing now that f of x is 3x minus 1, so we say 3 minus 2 times 3x minus 1. Okay? And then that will give us 3, okay? Minus 2 times 3, minus 2 times 3x will give you minus 6x. Then the same minus 2 times minus 1. This minus times minus will give you plus. Always notice that before I multiply numbers, I always multiply sign, because mathematics is funny. Make a little mistake with only one sign and everything is gone. You won't get the answer right. Okay, so always be careful dealing with signs. You multiply or divide the sign first before you deal with the numbers. Okay, here now we have minus 2 multiplying minus 3, because always take note of the sign before the number that you are using to multiply. Okay, so minus times positive 3, minus times plus is minus, so 2 times 3x is what? 6x. Then minus times minus here is plus, because when the same sign multiply, the answer is positive. Then 2 times minus 1 will be what? 2 times 1 now will be 2. Okay, you collect like terms. This is 3, this is 2. 3 plus 2 is 5, because they resemble each other, they look alike, they can add. The one that cannot add, you cannot add x. Okay, you cannot say 5 minus 6x. You cannot add them because they are not like terms. Okay, they don't belong to the same family. You only add or subtract numbers that belong to the same family, that look alike. Assuming we add another thing that has x, yes, the two of them will operate. in terms of plus and minus, okay? But here, it's only 6s, now only 6s waka come. And then we have what? So 3 and plus 2 will give you 5. So we have g of f of x is therefore equal to 3 plus 2, 5. That's 5 minus 6x. And that is the answer. Or you can say minus 6x plus 5. Anyhow, you are still correct. It depends on what comes out in the option. So we have just finished a topic called composite function. Practice with more examples. And if you have any question, you can always reach out. Bye.